So the next concept that we are going to discuss is the electric field due to an infinite plane sheet. Okay. So this is the last concept for this chapter. After that, we are done. So as the name suggests, right, you have a plane sheet like this. Let's say we have a plane sheet on which the charge is uniformly distributed. So it is distributed on both the sides. If you observe, when you look at the sheet in this way, if I directly show it to you, it is taking the shape of a rectangle. If I place it like this, right, in the projection view, you will be able to see only this line. But what I'm going to do is I'm neither going to place it like this nor like this. I'll place it in this way so that we are able to see the front side, but not exactly in the shape of a rectangle. Rather, we'll be able to see it something like this. On top of this sheet, what will happen is there is charge that is distributed uniformly. Okay. So due to this kind of a system, our job is to find what is the electric field at a distance r from it. So I'm going to consider a point P here, which is, let's say, at some distance r. Right. Now, first thing is we need to define the type of charge density. So what is the type of charge density we can define? It is going to be sigma, the surface charge density, because the charge is distributed over area. Right. So sigma, I'll call it as, for instance, I'll call it as Q divided by A, where Q is the total charge, A is the total area, but it is considered to be an infinite sheet, means it's a long plane sheet. Okay. Now, the thing is, we need to start thinking of a Gaussian surface which is symmetric about this charge distribution. So, in this scenario, unlike the previous cases, right, we can consider two types of Gaussian surfaces. One is going to be a cuboid or the other is going to be a cylinder. You can consider either of them. So, what I am trying to say is, if I consider a cylinder, right, if I consider a cylinder, then what is going to happen is the charge is there on this side as well as the back side. So the point P is here. I'll be considering the point P in such a way that it can be anywhere on the circle, right? Similarly, it can be anywhere on this circle as well, right? Then I'll take this distance as R, and when I join all those points, the shape I'm going to get is going to be a cylinder. Or else you can think of a cuboid also. Instead of taking the circular portion, if you replace everything with flat surfaces, it is going to look like a cuboid. Now, when I draw the same thing on this diagram, then it is going to look something like this. Is that clear? So it is going to look like a cylinder where I am taking this area to be A dash, for instance. And this area is also going to be A dash. I'm not taking it as pi r square or anything. I'm just taking it as A dash. Right. Now, if I look at this cylindrical Gaussian surface, how many faces does it have? 3. First flat surface, second flat surface, and the third curved surface. So the electric field due to this positive charge distribution is going to be in this direction. Let me call it as E. Similarly, there is a charge present on the back side of the paper. Due to that, the electric field is going to be in this direction, which will be called as the same E, because they both are at same distance. The magnitude is going to be the same, right? Now, if I take the total flux through all the three surfaces, flux through the first surface plus the flux through the second surface plus the flux through the third surface, what should that be equal to according to the Gauss law? So it should be equal to the total charge enclosed divided by epsilon naught. So what is the flux through the first surface? It is electric field that is coming out of the surface multiplied with what is the direction of this aerial vector. If I take a cylinder here, the direction of aerial vector is in this way. So electric field and aerial vector, they both are in same direction. So E into A into how much is going to be the value? Cos of 0 degrees. So which is 1 plus what about this surface? E into A dash. So I'm just replacing it with A dash. So E into A dash. Here how much is going to be? E into A dash cos 0, right? Plus the electric field is in this direction. For the curved surface, if you take my hand to be the curved surface, the areal vector is going to be in this direction for the curved surface. It is going to be perpendicular everywhere with respect to the electric field. So what is going to be the flux through the curved surface in this case? It will be a 0 because electric field and areal vector are perpendicular to each other. Having said this, how much is going to be the value of the charge enclosed? It is going to be sigma into the area. So sigma multiplied with what is this area? A dash. So it is going to be sigma into A dash divided by epsilon naught. So EA dash plus EA dash put together is going to be 2 times EA dash is equal to sigma into A dash divided by epsilon naught. So A dash and A dash get cancelled. So the electric field is going to be sigma divided by 2 epsilon naught, and the point to be noted here is this is the value of electric field due to one side of the sheet. This is not the total electric field. This side of the sheet is producing a value of E whose value is sigma divided by 2 epsilon naught. The other side will produce the same value, which is sigma by 2 epsilon naught. Right. Now for this shape, if I plot the graph between the electric field and the distance, how is it going to be? Sigma is a constant, 2 is a constant, epsilon naught is also a constant. So overall the electric field itself is constant. So for a constant, the graph will be a straight line which is parallel to the x-axis. So this is how the graph will look like. And secondly, we discussed this concept, if you remember, torque experienced by a dipole placed in uniform electric field. Remember? So I drew a set of parallel lines, right? So who's the source of that uniform electric field? If someone puts a question like this, then you can say it's a plane sheet. So an infinite plane sheet is going to generate uniform electric field. It is only for one side of the sheet. One no, but what is the value of E that you have taken? This is E, this is E, right? They both are two different values. They both are two different E's, though they have the same magnitude, right? But how many such E's did you find? You found only one. That could either be this E or this E, it cannot be a combined effect. So why I'm stressing on this point is we'll use this concept in the next chapter in a topic called as parallel plate capacitor. There, this is the exact value we'll be using. So at that time, if you miss the two, you will get completely different answers. You're clear? So that is the reason why I'm stressing it here. There is the electric field due to one side of the sheet. There is electric field due to one side of the sheet. Am I clear with this? Is everything clear? Please make a note of it.